All right, we are moving on. We skipped some sections because we ended our quiz at 4.3. We're going to talk about solving rational equations. So rational equations, solving again means that you have to find x, and rational just means it's a fraction. So we're going to solve rational equations. You're going to have to find a common denominator. You have to find x by factoring, and then you have to check for these things called extraneous solutions, and those are just answers that don't work. Okay, so the first step when you're looking at these is always to factor. And if you factor right, you'll probably find that all the factors kind of match up. So the thing that I'm going to factor first is this n squared plus n, and it has a common factor of n. So I'm going to factor that out. And then you'll see like the n's match, and then the n plus 1 matches. So my common denominator here is going to be n times n plus 1. Okay, so the tricky part about these is coming up with the common denominator. Usually it's just multiplying both things together. So when I rewrite this, I am going to write it one more time for myself, and then I have, so over here I have 1 plus n, or 1 over n. I'm going to give myself a little space, plus 1 over n plus 1 equals 1. 1 as a fraction is 1 over 1. So you should write everything as a fraction, plus 1 over n times n plus 1. So my common denominator, like I said again, is n times n plus 1. So over here, I'm going to think to myself every time, what am I missing in the denominator? So I just have n here. I'm missing n plus 1. So I need to multiply both the top and the bottom by n plus 1. Over here, I'm missing n. So I'm going to multiply both pieces by n here because I'm missing n on both of these. For the denominator of 1, I'm missing both n plus 1 and n. 1 doesn't have either one of these things, so I have to do it to both the top and the bottom. And my last piece over here has everything it needs, so I'm good. So now I'm going to kind of multiply through, and again, hit pause if you're confused, and write this down, and then here I go for my next step. So I just have n plus 1 in the numerator, and then I have my common denominator down here in the denominator, and I'm not going to FOIL it through or anything, because I just want to leave it as a common denominator, equals n times n plus 1 over n times n plus 1 plus 1 over n times n plus 1. Okay, so if you're asking yourself, why did I find a common denominator? I cannot add any of these things together or solve for x until I find a common denominator. So just like if I did 2/3 plus 1/5, I can't add these until I find a common denominator, and the common denominator of this one is 15. So I'd multiply this both by 5 and this both by 3, and I have 10/15 plus 3/15. My answer would be 13/15. Okay, so that was just like a, why am I doing this? Okay. Now I can add across the numerator, so I'm going back to my original problem. So across the numerator, I have n plus 1 plus n all over my common denominator. And over here, I have n times n plus 1 plus 1 all over my common denominator. Okay? That's not what I wanted to do. Need some more space. So at this point, I want to get rid of my denominator because I've got too much going on here. And what I can do is make an algebra move where I multiply both sides by the same thing. So for example, if I have, I'm going to use a number 1 again. Okay, if I have this, wouldn't it be true that 5 equals x? Or I could multiply both sides by 2, and that would get rid of my denominator in both cases, and I would end up with the equation 5 equals x. That's essentially what I'm going to do here. I'm going to kind of erase this and go back to our problem, where what I'm going to do now is multiply both sides by the denominator, because when I do that, the denominator goes away. Okay, and it doesn't necessarily go away as much as it makes things simpler for us because we know that if the denominators are the same, then the numerators are, we can set equal and solve. So on this side I have 2n plus 1, and this side I have n squared plus n, I distributed that, plus 1. And I can't solve this the way it is, but I can turn it into a quadratic that I can factor. So I'm going to have n squared minus n equals 0. Factor out an n. My last step is to solve, so n will equal 0 or 1. So the last step of this is to check to make sure that your answers work. Because if I plug in 0, for example, if I plug in 0 right up here, what would happen is you would get 1 over 0, and that can't happen. So 0 is what we're going to call the extraneous solution, meaning it's extra and it doesn't work. And I can plug in 1 and still get an answer, but I can't plug in 0. So again, the first step on this one is to find a common denominator, and you need to start by factoring. So, of course, we're lucky that these are our factors. So our common denominator is going to be both of these together, x minus 2 and x minus 3. So x minus 2 and x plus 3. I think it's helpful to write your common denominator down. So you're going to look at these, and every time you look at one of them, you're going to think, like, what do I still need? So this one still needs an x minus 2 in the denominator. It should be an x. I wrote n again. This one is good. It has both factors. This one needs an x plus 3. Remember, you have to do it to both the numerator and the denominator. Okay, and now I'm going to rewrite what I have with our common denominator. So in the numerator here, I have x minus 2 times 2x minus 1 plus 1 all over our common denominator equals 4 minus x times x plus 3 all over our common denominator. Okay, so here's the step now where we multiply both sides by the common denominator. Okay, so over here too, pretend I'm multiplying, and then these cancel. And we have to go back to them, but to solve, we don't need them. So you're going to have to practice your foiling here because we need our foiling. So when I FOIL here on the left side, I get 2x squared minus x minus 4x plus 2 plus 1. So I'm going to just combine my like terms here. Plus 3. And then over here, I'm going to get 4x plus 12 minus x squared minus 3x, which will boil down to, okay, I'm not certain that there are no mistakes, so hopefully I did this one correct, and this is a minus. So what I'm going to do next is try to get them all on one side so that I can either factor or quadratic formula or whatever I need to do. So I'm going to add x squared, subtract x, and subtract 12. So I've got 3x squared minus 6x minus 9 here. I'm running out of room, so I'm going to move this up. The first thing I noticed is that they all have a 3 in common, so I'm going to take out the GCF of 3. And when that happens, this becomes something I can factor. So I'm going to factor this. This 3 out here won't cause me any problems. I can still find my zeros. So this is the answer. Like, I now solved it, but what I need to do now is to go back and check. So I'm going to shrink this down and go back and check and ask myself, like, if I put in 3, I'd have 6 on the bottom over here. I can get a laser pointer, I think. Here we go. So if I plug it in right here, 3 plus 3 is 6, and negative 1 plus 3 is 2, so I can use it there. And same thing over here, 3 minus 2 is 1, and negative 1 minus 2 is negative 3, so I never make a denominator turn to 0, so I'm good, and both of my answers work. This is the last example, and it's a word problem. So Marcus made 13 out of his last 20 shots. So if you think about this, 13 out of 20, and then you use your calculator to find maybe what that percentage is. So I'm going to type it in, 13 divided by 20, and I got 65%. So right now he's sitting at 65%. And he wants to know how many more baskets does he need. So this is a keyword, how many more? Because when I'm setting this up, I'm going to say I have 13 baskets now, and I want to add some more. But when I do that, I'm also going to add more to my total shots, right? So if I take one more shot and made it, I'd be at 14 out of 21. Or if I didn't make it, I'd be at 13 out of 21. So I want to add to both my made shots and my total shots. And in the end, I want this to be 80%. And I want to write 80% as a fraction because I like that. And this is how I would write it. You can write 0.8. You could write 8 over 10. But this one is different because I don't as much have to come up with a common denominator as I can just cross multiply. And this is something you guys already know how to do. So when I cross multiply, I'm going to set it up like this. And then I'm going to distribute. So I get 1300 plus 100x equals 80 times 20 is 1600 plus 80x. Okay, and so now I'm going to try to move all of my numbers to one side and x's to the other. And move this over. So 20x equals 300. And if you take 300 and divide by 20, I get x equals 15. So that's what we think, how many more shots Marcus needs to make in order to raise his percentage. If we plug that in, right here, let's try it and say 13 plus 15 is 28 out of 20 plus 15, 35. And if I take 28 and divide by 35, I do get 80%.